Okay, so we're going to look at some counterexample practice questions. So the instructions are going to say, decide if the following statements are true or false. If they're false, then provide a counterexample to show that the conjecture is false. If they're true, they're true. You won't have to do anything. But if they're false, you'll have to draw a picture, which is the best way to get a counterexample. Now, counterexamples, if you were reading, counterexamples can be pictures or they can be words to come up with a counterexample. Some of you did both on the homework. I always draw pictures. I think they're easier for counterexamples. So if you can think of a picture that would prove someone wrong, then that's probably the easiest way to do a counterexample. Okay, number one. If two angles are supplementary, then they form a linear pair. You actually had this in the bookwork. And I told you on Canvas that some of you missed this problem, so I want to go back over this. If two angles are supplementary, then they form a linear pair. That is a false statement. It is a false conjecture. So what I have to do is think of a way to prove Mrs. Wien wrong. So to do that, I would need to think of a time when two angles are supplementary, but they're not forming a linear pair. So what I would do is I would come down here and I would sketch two angles that are supplementary but don't form a linear pair. So I think back to the fact that two angles could be supplementary but not adjacent. So then I'm going to put fake measurements in. I can pick whatever I want. I just need to make sure that those two angles add up to 180, which shows they're supplementary, but they're not adjacent to each other, so they're not a linear pair. This is called a counterexample, and you only need one counterexample to prove somebody's wrong. So this would prove me wrong, and then I would know that my conjecture was actually false. So I need to start over and make a new conjecture. Okay, so let's try another one. If JK equals KL, then K is the midpoint of JL. So when you first think about this, you might think, oh, this is true. If these two segments match, then K would be the midpoint. But is there a way that you could draw this where these two segments match each other in length, but K is not a midpoint? And keep in mind, K has to be the same point because you can't have two Ks. Okay, so I'm going to think of a way that I could draw this where JK was equal to KL. So I'm going to tick them to show they're equal. But is K a midpoint in this case? No, because it bends. It's like an angle. So to be a midpoint, you have to be in the same line with each other, and these are not. So this would be a counterexample to that conjecture, which would prove me false, which would mean that this is a bad conjecture because the counterexample proved me wrong. All right? Okay, last one. If angle ABC is congruent to angle DBE, then ABC and DBE are vertical angles. Well, we know vertical angles are congruent, but are all congruent angles vertical? And so the answer to that is going to be no. So this is another bad conjecture. So this is another false conjecture, and I need one counterexample to prove it wrong. So all I have to do is just draw ABC and DBE. Oops. So I'm just going to go A, B, C, and D, B, E. And I'm not even going to make them vertical. In fact, I'm not even going to make them adjacent to each other. I mean, you could draw this all different ways. I just need to show that these are congruent. So I'm going to put an arc here and an arc here. Or I could put like 40 degrees and 40 degrees. These are congruent, but they are definitely not vertical because they're not even adjacent to each other. Or I should say across from each other. They're not even made by two intersecting lines. So you can have congruent angles, and they wouldn't necessarily have to be vertical. So that is called a counterexample.